Alright, this is our unit about functions and how we describe functions and talk about functions, and the topic is domain and range, and there'll actually be two videos that I do. This first one covers finding domain and range when you're given a relation, and sometimes those relations are functions, and that relation is expressed as either a set of ordered pairs like it is right here, or a mapping diagram as it is there, or this third way that we'll discuss in this video as a graph. Okay, so three ways to determine domain and range, or three different ways to express a relation and how to find their domain and range. Let's look at the first one, the set notation. And what we should remember is that domain are the input values or the x values in general. Usually it's the x values, depends on what your variables are named though. And the range is then what comes out, which is usually, you should put output there, usually the y values. Okay, so in set notation, it's pretty explicit which ones are x and which ones are y. And so then we just say, all right, my domain, we can use D to symbolize that. Since we can list these, we'll just say it's this set of numbers. We get 1, -1, and 4. And when we put that set down, we usually list the domain values in order from least to greatest. So there's the domain of that relation. And the range is simply the y values, the things that they're paired with. So in this case, my range, again in order, -1, 2, and 3. If they're not in order, it doesn't matter. It's a set of numbers. So order doesn't matter. It's just nicer to see them that way. Okay, the mapping diagram, very simple again. There's our x values on the left and our y values on the right. So our domain is the x values 1, 2, and 3, and our range is simply one value, just the 4. Okay, and all these things, when we list our domain and our range, all they're doing is saying, hey, these are the values that x can be, and these are the values that y can be. It doesn't tell you how they're paired up or anything. It's just giving a listing, and it really isn't that super valuable when they are just these discrete sets, just a finite number of items in there. Let's look at this graph now. Graphs, we can illustrate a lot of points more simply. Way more points than we could ever list are shown on this graph. Remember, a smooth line like this represents an infinite number of points, and we're going to make sure we get an infinite. We're going to make sure that we get the arrow saying this parabola that's laying on its side goes on and on forever. Just as a review note, this is not a function. It would flunk the vertical line test. We can still declare or state what its domain and range are, though. The domain are x values. Let me get rid of that bracket. We may not need it and don't need it. X values are what x's are used to make this graph. Well, to find our x values, we have to look along the x-axis here, and we can see the furthest left point is right there at this vertex of that parabola. That's as low as the x values go. If I go past it, down here at -6, there's no graph that I intersect with a vertical line. So that's no x values are graphed out there. Okay, so I say, well, it looks like, and I'm just going to count here, a -4 is that tick on top right there. So negative, let's see, 1, 2, 3, 4, 5. There's 5 in between there. Yeah, that must be right at -5 right there. So that vertex on the x-axis is right at x equals -5. And you just got to look really close at the graph to tell that. And now I look, so there's the lowest value for x that's graphed. And I look at all these values that are bigger than -5, and every single point I go to, on the x-axis it isn't there, but it corresponds to a point up there on the curve. Or it also corresponds to points down here. In fact, every single x as I go to the right has a point on the graph somewhere that has that x coordinate or x value. So all the x's that are bigger than or equal to -5 are used in constructing that graph. And that's what my domain is going to say now. My domain, I'll use interval notation for this. It starts at -5, including the -5, and goes to the right forever, or it goes to positive infinity forever. I'm sure that's kind of a little redundant, going towards positive infinity forever, but it just heads to positive infinity. So here's our domain. I'm going to put my arrows on my graph. Range, on the other hand, are what y values were used to make this graph. Now if I look at the lowest y value, and I kind of draw horizontal lines here saying, hey, is there any spot I can draw a horizontal line where this graph stops and will never hit? But this graph, remember, because of the arrows, goes on and on forever. It's going to go down forever as it goes to the right. Same way up here, it goes up and up forever. 0 is graphed out here, 1 is graphed out there, 2 gets graphed. Every single y value you can think of gets graphed to a point that is on our y-axis. Now because of that, since every single y value gets used in constructing this parabola laying on its side, we have to tell the person who looks at it that, hey, your range, your y values used are every single value. There's a couple ways to do that. In interval notation, we just say the y's up and down go from -infinity all the way to positive infinity. We could also just say it's all real numbers because any y value works. We saw inequality notation. I'm not a fan of this, but it'll work. I like that. It's between infinity and -infinity. So all of those are statements of what the domain and range is for that graph. I'm going to draw one quick other one here so you can see it again. This one I'll just make up. So we're going to draw a graph here. And let's make this kind of crazy looking absolute value function. We'll use those as our tick marks. So use the blue lines, so there's 1, 2, 3, etc., -1, -2, -3, etc. Let's say you want domain and range for that. So domain, I look left and I look right, and I say, okay, is there any x value that isn't used? And I say, no, this thing starts basically at 2 in the x, right there, and then there's points all the way to the right. They're on the blue line, but I'm just showing them in the x direction, and to the left. So domain, all real numbers, and again, interval notation, -infinity to infinity. This graph goes left and right forever, and all the x's are used. For my range, the y values, I'd say, oh, look at that, this thing doesn't start until y is -2, and then it goes up forever. They go outward too, but they go up, starting from -2. So I say, hey, it starts at -2, and it goes up for forever. And that is my range.